LJ Institute of Engineering and Technology, Department of Instrumentation and Control. Our subject is Safety Instrumented System. Unit 7, Choosing a Technology. In last session, we have started Unit 7 and we have discussed PLC, relay and solid state system. So let's start today's session. In today's session, we will discuss remaining part of solid state system. Whichever solid state system one may consider, all of them offer similar construction, and we will discuss this figure in next slide. There are individual modules for inputs, outputs and logic functions. These systems do not use multiple channel input-output cards like PLC. The modules must be wired into the logic configuration required. This may involve literally miles of wire in some system. Okay, so let's see diagram of this system. Here you can see in this diagram sensors are available. Okay, sensors connected with input, digital input and analog input. Then after this signal sent to the logic modules. Logic modules we are consider and timer or gate. Okay. Then after signal sent to the output and output to the signal sent to the control wire actuators in our system. So this is a figure 7.1. Okay, and basic diagram of solid state system. Thereafter next, when you stop and consider all of the details engineering and manufacturing required, it's no wonder these systems are so expensive. The primary use for solid state systems are small, high safety integrated level SIL application. Two vendors have systems certified for use in SIL. Okay. So here primary use for solid state system are small and high safety integrated level. Okay. And vendors have certified to this system. One English document recommended the use of these systems and not software-based system for small offset application with SIL3 or greater requirements. Okay, so here you can see documents are required for standards. Then after next is microprocessor and PLC software based system. Software based systems are utilized in largest percentage of application. There is no technical imperative, however, that say we must use microprocessor based system. Okay, so for improvement, okay, we have to use microprocessor or PLC based system. Programmable logic controller were originally designed to replace relay. Their use in safety system would therefore seem inevitable as their application in safety requires close scrutiny. Okay. Thereafter, next, software-based systems offer a number of advantages. So let's see advantage: reasonable cost, then ease and flexibility in making changes, serial communications, graphic operator interfaces, self-documenting, small footprint. Okay, so these are basic advantages of microprocessor and PLC based system. So next, General purpose PLCs, however, were not designed for use in critical safety application. Most units do not have the diagnostic capabilities, fail safe characteristic or effective levels of redundancy for use beyond SIL1 applications. So see, so number 1, flexibility, cure or crush. Now then after number 2, software issues. Then 3, general purpose PLCs. Okay. So this is some problem, right? And issue regarding our system. So next is first flexibility, cure or crush. Then flexibility, that is the ease of making changes, offer benefits for some but introduce potential problems. The ease of making changes will no doubt encourage actually making changes unless effective management of change, that is MOC, procedures are in place. This can easily lead to additional complexity and introduce new errors. Flexibility encourages redefinition of tasks late in the development phases or even after installation in order to overcome deficiencies found elsewhere in the system. John Short phrased it well with software is the place of afterthoughts. Flexibility also encourages premature construction. Few engineers would start to build a chemical plant before the design had finished the detailed plans, and this often happens with software-based systems. Flexibility also allows unique and sometimes unproven techniques to be used. Similarly, few engineers would design a complex system such as jet aircraft after having only built a model. Then after next, hardwired system impose physical limitation on the design of a system. This helps control complexity. After all, you can only connect so many wires, timers and relay in a given panel. In contrast, software has no corresponding physical limits. It's possible to build extremely complex software-based system. Then after next, the level of automatic internal diagnostic with software-based system varies considerably. Since most general purpose PLCs were designed for active dynamic control, they do not have a need for extensive diagnostics. Most failures are self-revealing in active control system, and diagnostic only increase their cost. This lack of diagnostic tends to be the primary weak link this system as far as safety is concerned. Okay, so here we have discussed about flexibility, right? Thereafter, software issue. This has to do with two areas, reliability and security. How many programmers, when they are through with a project, also most programmable system after very little in terms of access security. Therefore, many software-based systems utilize some form of redundancy, usually of the main processor. One issue associated with redundant system is common cause. Common cause is a single stressor or fault that can make redundant items fail. Then after, software is one such potential problem. If there is a break in software, the entire redundant system may not operate properly. If you have any question in this session, then you can ask me. Thank you for watching video.